Okay, all right, so this is the last video of the chapter. And again, this is actually short. There's only 6 questions here. This is all over direct and inverse variation. We have some joint variation in there as well, but it's just over the different types of variations. Okay, when we see a direct relationship, that's going to be as one increases, so does the other. Okay, and I have this ratio of constants. So if I go and buy gas, if I buy a gallon of gas, for easy math, we'll do $2. Okay, so the cost is going to be $2 to my credit card. If I decide to buy 3 gallons of gas, okay, that the constant was $2 a gallon, so that my credit card gets $6. So as the number of gallons bought increases, the number that gets charged to my credit card also increases. So in a direct relationship, as one variable increases, the other variable is going to increase. Okay, these can also be solved by doing proportions. Okay, so what we could do if we wanted to, x over y equals x over y, that works here. Okay, if we're doing an inverse variation, okay, that's when as one variable increases, the other one is going to decrease. So if I buy a $10 pizza, and if I only have myself eating it, it just costs me $10. Okay, if 2 people go in on the pizza, so let's say we have this $10 pizza, but now we're going to divide it 2 ways. Okay, now it's only costing $5 per person. If we divide it 3 ways, okay, now it's only going to cost me $3.33 a person. Okay, so as the number of people increased, the price that each person had to contribute decreased. Okay, that's an inverse relationship. It also decreases the amount of pizza you get to eat, but that's not what we're after here. We're just talking about the relationship. And then this one, though, this one's going to be this one we don't do very often, but they're going to be equal products. Okay, that's just how those works. And joint variation, I wrote it out there, but it doesn't really make any difference at all. If we talk about number one, it tells me as I read it, and I just have to read through it if I write it down as I see it, and then this is so straightforward. If y varies directly as x, so since it's a direct variation, we have this, okay? And we know that y equals 9 when x equals 7. So they're going to give me some numbers to figure out my constant of variation. So we have to figure out what k is. We're going to divide the 7 across. So k is going to equal 9/7. So the equation that we're working with here is y equals 9/7 x. And then it says find y when x is 14. So 7 crosses out of 14, goes in there twice. 2 times 9 is 18. So my final answer is 18. Y equals 18 is going to go into my answer block. Okay? 2. Again, I'm just going to read the question and write it down. Y varies inversely as x. So there we have it. We have an equation to start with. Now it's just dropping in the amounts that we know. And y equals 17 when x equals 3. Find y when. Okay, so let's figure out what this constant variation is. We're going to multiply by 3. And we're going to find out that 51 is equal to k. So that means we have y equals 51 over x. So that's the equation that we're going to roll with. And it said find y when x equals 9. So now we just got to find 51 is not divisible by 9. So I guess we just have to reduce that. Divisible by 3, so y equals 17 thirds. Okay. Number 3, it is just reading the equation, writing it down, and then substituting and solving. So it says y varies directly as x and inversely as the square of z. Okay, so there it is. We did the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The first 12 words gave me my equation that we're going to work with here. Now it tells me that y is 32 when x is 64 and z is 4. Okay, so all we did was we plugged y, x, and z into my equation so I can figure out what k is. Okay, so I know that 4 squared is 16. So again, it's however we want to simplify 64 times k all over 16. Now I'm going to roll with this. 16 goes into 64. I believe that would be 4 times. And now the 4k equals 32. So we're going to divide that 4 across and find out that 8 is equal to k. So my equation here is y equals 8x all over z squared. And now it says find y when x equals 40 and z equals 2. So 2 squared is 4. 4 goes into 40 10 times, so all of that simplifies into a 10. When I take 8 times 10, I'm going to get 80. And we are done. Okay. I'm going to come up here and do number 4. It says that an alligator's tail length T varies directly as its body length B. Okay, now technically speaking, we could solve this proportion. I'll do that at the end. An alligator with a body length, okay, so the body length is 4.9. Has a tail length of 3.5. So we can figure out what my variation of constant is by dividing by 4.9. We get 0.71438. We're supposed to, it says to round the nearest tenth as needed. So we're going to round our final answer, but we're going to leave this as k equals 0.71429. Okay, gives me plenty to work with. So that means that the tail of the alligator is roughly 71% of its body length. Okay, that's what that's telling us. Now it says, what is the tail length of an alligator whose body length is 4.2? So we'll drop that in there, and we'll just leave that in my calculator. We'll take that times 4.2. We're going to round that, and that turns out to be a 3 in reality, since I didn't round anything. So there we go. I left it all in my calculator, and it turned out great. Again, I said we can also do this as a proportion. So alligator 1, so we can have tail length, body length, and we can just keep that ratio going. So the tail length was 3.5, the body length was 4.9. It's going to be the same as an alligator having an unknown tail length, but having a body length of 4.2. Okay, that's going to get me to the same exact thing. If I cross multiply and divide, I would multiply those two numbers and then divide by this number, and it's going to lead me to the same exact spot. Okay, here's 5. The number of kilograms of water in a human body varies directly as the mass. Okay, so the kilograms of water varies directly as the mass of the person. A 90 kilogram person contains 60 kilograms of water. So K is equal to 2/3. So what it's saying is it's 2/3 of your body mass is water. Okay. And finally, a 90 kilogram person. Oh, how many kilograms of water are in a person that weighs 72 kilograms? So the weight of a person is going to be the weight of water is 2/3 the body mass. It tells me that I have a person that has a body mass of 72. So we're going to take 2/3 of 72. Okay. Brain's not going to work like that. So here we go. 2 divided by 3 times 72. That is going to be 48. So 48 kilograms. All right. This was nice and short. Here we are, number 6. Radiation machines are used to treat tumors. They produce an intensity of radiation that varies inversely as the square of the distance from the machine. Okay, so again, if we just talk it through and write it down as it reads, it's going to tell me what to do. So here we are. At 3 meters, the radiation intensity is 62.5 milliröntgens, whatever that is, per hour. What is the intensity at a distance of 1.8? So here we go. This is 9. So we're going to take 62.5 times 9. 62.5 times 9 is 562.5. So that means the intensity from radiation is going to be 562.5 divided by the distance squared. And we're asked to find what is the intensity of radiation when I am 1.8 units, meters from the machine. So here it is. And this is 50, okay, so cleared. Divided by, nope. Previous answer. Divided by 1.8 squared is 173.6. And the units are already in there for us, so we didn't have to worry about it. All right. We knocked that baby out in 12 minutes. So there we go. All right.